Hi, and welcome to Dear SQL DBA, a podcast for SQL Server database administrators. I'm Kendra Little. Welcome to this episode. I'm going to talk today about whether or not you can use statistics in SQL Server to design indexes. Here is today's question. Dear SQL DBA, I've noticed that many indexes in my data warehouse aren't used frequently. Is there a way to use the automatically generated statistics to make useful indexes? Sincerely, insert witty pun about indexes here. Well, I've actually been asked this question several times over the years, and the word statistics can get used a couple different ways in SQL Server, so I responded back and said, do you mean the automatically generated column statistics? And they said, yes, those are what I mean. I said, okay. I actually remember wondering this myself once as well. I first learned about statistics in SQL Server when I was a database administrator troubleshooting problems with slow queries. And so I kind of learned at first just enough about what I needed to do to sort of make the current problem go away. But I didn't learn the full story about really what statistics and indexes are until some time had passed. And here's the answer. There is not a good way to analyze the automatically generated column statistics in SQL Server to tune or create your indexes. There's other ways to do it though. And it is good to help sort of understand why the statistics aren't useful for index design and how statistics and indexes are related, because they are absolutely related in sort of like in the family reunion. They're pretty close relatives. So first up, why do we have statistics anyway? So let's say we have a table that has grades in it, dbo.grades. And we've got columns for, like, we've got a grade ID, which is a unique, integer or big int that identifies the row. So every time a row is inserted, it gets a grade ID. There's class ID, student ID, maybe year, the term, and the grade itself. So we got a lot of columns in there. And we happen to run a query that says we want to get all of the student IDs where year equals 1990, say. The table has a clustered primary key on that grade ID column. So the whole table, all of the columns together, are ordered by this grade ID. And we aren't even using that grade ID in our query. We just want the student ID where the year is 1990. So the order of the table, we can't just go to a specific part of the table to find the 1990s. They could be anywhere in that table. We do have a non-clustered index on the table that is on year. The non-clustered index has two key columns. It has year and then it has grade ID, that clustered primary key in it. It doesn't have student ID in it though. So if this is what we've got, our SQL Server would have a couple of options, right? It could go and say, okay, well, you want all the students from 1990. So this non-clustered index, I could go use the non-clustered index to find all of the rows for 1990. You want to return the student ID though, and it's not in that non-clustered index. So for every row for 1990 in that non-clustered index, I could take the grade ID and go back to the base table and find, okay, for that grade ID, what is the student ID? And I could get all the data that way. Or if that's a lot of the table, you know what I mean? Like, what if the school actually was only open for the year 1990? It's possible that every single row in my table actually is for 1990. So in that case, it might be easier to just use all of the, multiple cores that I have available and just look at every row in the base table and look at student ID on every row, right? How does SQL Server know which is going to be more efficient for your grades table? Well, statistics are the little piece of magic that helps it estimate, hey, how many times, if I use that non-clustered index, how many times am I going to go have to look up the row in the table? Or is the table just mostly that data anyway, in which case I'll just go scan the table. Whenever you create an index in SQL Server, it knows automatically. It's like, oh, well, if you're going to create that index on the year column with grade ID after it, I should probably have a statistic along with the index to help me know when that index is useful. So whenever you do create an index, it creates a statistic related to the key columns in that index for you. You don't have to ask. And in fact, you can't tell it not to. It's going to do it whether you want it or not. Because it needs it to know when it should use the index. And the statistic is a little bitty tiny thing that contains summary information about the table. And this information is not expected to be fully accurate. It's just kind of an overview. Things like about how many rows does it have. It won't update it every time you add a new row. It only updates these periodically. Things like about how unique are the values in this column. And then for it in this multi-column index, for the first column, it has just a little histogram with up to 200, 201 steps maximum that'll just summarize, okay, what years do I have? About how many rows do they have? And about how many rows are between them? And that histogram won't necessarily contain every value, right? Because it can only have a certain number of steps. So it just sort of uses it to estimate. The statistic is not trusted. It's not the data in the table itself. It just describes it. And it's summary. So it's nice and little bitty. Doesn't take up a ton of room. So that's when I create an index, I necessarily get that. And then let's say I didn't have an index on year. If I ran a query that said, how many rows am I going to get back for year equals 1990? SQL Server, let's say I was doing a count. I need to count all the rows for 1990. SQL Server might need to allocate some memory for that query to do the count. Depending on, how complex my query is and what I'm doing, I might need to allocate a lot of memory for different things. Knowing how many rows it's going to get back for 1990, even if it's a whole choice is to scan the table, it's going to create a column statistic, a small statistic just on that column in the predicate that describes, hey, how many rows do I have and how are they distributed for different values? And again, it's nice and little bitty. It just helps it make decisions about which indexes am I going to use? What types of joins am I going to use? Am I going to go use TempDB to help do my join? When I'm allocating memory, about how much do I need to do? And the statistics are those tiny little pieces of metadata help it optimize that execution plan. So our little bitty statistics help it make the decisions about how to run the query. Whereas comparatively, when you create an index in SQL Server, the index itself is a copy of the data for the columns that you define in the index. Indexes can take up a lot of room, and the indexes are used to, find the data and pull it back to the user. So I use a statistic to help decide how to run a query. The index is going to be what I possibly access to get the data back. Although it can decide, hey, I don't even want to use the index you created if you're not forcing me to use it, and I might just go scan the base table or, do whatever is the valid best way to get the data back, right? So that's the relationship between indexes and statistics. And this is why this relationship is pretty close. So it seems like, well, can I use, does the fact that it created a statistic help me about how to design an index? Well, not really. In fact, it doesn't. Because when we think about optimization in SQL Server, there's a couple things. Optimization has to be really fast. You don't want to sit and wait for a full minute for SQL Server to figure out how to run the query before it even starts running the query. We want SQL Server to we want it to make great decisions about how to run the query, but we want it to do it really, really fast. It will consider a lot of statistics in the process of making this decision. And some of the statistics that it considers, it's going to decide, oh, well, I looked at that index statistic, but I didn't want to use the index after all. Or I looked at the column statistic, but I actually decided to look at this other index. I decided not to scan the base table. So if it were to record information about statistics and part of optimization, it would actually have to record a lot of information about them. And I don't actually think it would end up being very useful either, because just because SQL Server considered a column statistic, I don't necessarily need to create a single column index on that column. It might be that I need to create a multi-column index with multiple columns. It might be that it actually was better off scanning the base table and I don't need to create the index. So the fact that it thought about the column doesn't mean I should index it. We also have another feature that does this for us. So this was thought about. During optimization, if SQL Server sees that there's more than one way to run a query, because sometimes there is actually only one way to run a query. Sometimes we have a tiny little table and maybe it just has a clustered index, or possibly it has no indexes at all. And the only option SQL Server has is to scan it. If it's a really simple query and there's really no choices for it to make, it does something called trivial optimization. It just says, here's your query, there's only one way to do it. But if it has to actually do some thinking and goes into full optimization, one of the things that it does is consider, is there an index that I don't have that would make this query faster? And if there is, it records it in the missing index dynamic management views. So in a way, like, it's using the statistics as part of optimization. It's actually using the information it got from them to make this recommendation about missing indexes. So it's actually doing what we want. It's just summarizing it out at the level of saying, here's a summary of information that goes into the missing index, because it gives you like equality columns and inequality columns and then a recommendation for included columns. So it's trying to help you figure out what might be good key and included columns. So it's just summarizing it up for you. It already does that. And that's why I'm like, yeah, the more fine-grained information about the statistics wouldn't necessarily help me. You're already summarizing it for me and telling me sort of, I think this index, and giving me the multiple columns that it thinks would help. It's already giving me that information. Now, that information isn't perfect. I don't want to make it sound that way, but the other information wouldn't be perfect either. I also wouldn't jump to any conclusions if a column does not have a statistic created on it. So let's say we're looking at our grades table and there's some column in there that just doesn't have an automatically created statistic on it. Well, that's okay. It doesn't mean that the column isn't being used. The automatically created statistics, like, we're talking about them in terms of like filters and predicates, right? Well, what if I'm always just returning? I'm not putting that column in a join or a where clause. I'm just returning it in a select. Well, I wouldn't need a statistic for that, right? And that column might even sometimes be useful as what's called an included column in an index, depending on the situation. It actually might still play a role in indexing. So if a column, I wouldn't look at columns to see if they do or don't have statistics as like part of a decision on whether I can get rid of the column either. I don't think that works either. It seems like it might, but then you start thinking about it and you're like, oh, well, just because it doesn't have a statistic, it might still be a critically used, frequently accessed column, actually. So what is the best way to actually design indexes? If looking at the statistics there isn't the answer, what is? Well, there's really two main approaches, and I'm just going to kind of summarize them here because that's a whole nother story. These two approaches aren't really exclusive of one another. After you get to tuning indexes for a while, you'll probably use a mixed approach among these two. The first approach, and one that I really love, I tend to prefer this approach, is to identify the most expensive queries in the database and then tune those queries to be the fastest. And my cat has come into the room and she agrees with this method. She really likes that. She's spent a lot of time with me when I've been index tuning. So what does most expensive mean? Usually you kind of slice and dice this a couple different ways. I would want to look at which queries use the most CPU, which queries are running at the most critical times, and then also if I have any just super frequently run queries, they might individually use a very small amount of CPU, but if something's running like 5,000 times a minute, I really want to tune it to make it as efficient as possible if it needs to run 5,000 times a minute. Finding these most expensive queries can be done with the SQL Server query store feature that's been recently introduced. You can use the SQL Server execution plan cache, or you can use a monitoring tool that looks at what queries are running, what are their plans, what are their index requests, and persists that over time so that your execution plan cache getting cleared out by recompiles or memory pressure or restarting the instance, doesn't totally screw up your tuning process. So strategy 1 is tuning your top queries. Strategy 2, which isn't my favorite but I still look at, is that missing index request feature in SQL Server. And often, if you get really into looking at the top queries, you'll go look at the missing index requests and you'll see, oh, okay, the top indexes that it's asking for, the things in this DMV that it's asking for, I already saw the queries related to those in my top index requests, and I've taken care of them. I'll go and check it to make sure that is there like some index that it's asking for there that for some reason I haven't seen in my top queries. Maybe I'm looking at the plan cache and it did get cleared, or maybe I've missed something. I kind of use it to double check my work. The reason I prefer the top queries approach is, like I said, the missing index feature isn't perfect. Sometimes it'll recommend something as an included column that would really be better in the keys. It doesn't tell me what I want to do for key order. Knowing the queries can help that. And then also, like I mentioned for that, if there's only one way to run the query, it won't always make a request for those really simple queries, but yet it might actually be some of my top queries that it's not asking because there's only one way that it can run the query. So both the top query approach and looking at the missing index requests, I think, are really, really useful tools. And those are the approaches that I take when I'm saying, hey, how can I improve the indexes in this database? So thank you so much for this great question. And this question really excites me. I'm giving a one-day pre-con on index tuning and talking a lot about execution plans and how to look at those top queries and design indexes from them. So I've been polishing my slides on that. I'm giving that at the SQL Pass Summit, which is coming up in, I think, 3 weeks now, just a few weeks away. So really super excited. I just said super excited, but I actually am really excited about that. And if anyone listening is going to be at that session, I cannot wait, and I am looking forward to seeing you guys there. Thanks for joining me for Dear SQL DBA this week. I'm Kendra Little, and I will see you again next week.